Okay, on to our first lesson. The first thing that we're going to cover is going to be strings. And in order to do that, I'm going to go ahead and make a directory on my Linux machine. You can make a folder in your Mac or your Windows machine if you're using those operating systems. I'm just going to go in here and just say make dir python, and then I'm going to go ahead and go into that directory. So from here, I'm going to go ahead and make my first script. So I'm going to clear my screen with Control L, and I'm going to say mousepad, and I'm just going to call this script first.py. And I'm going to give it the ampersand here at the end. That's just going to allow me to open up this process of mousepad and also have the terminal available to me when I need it. So you'll see why I do that here in a little bit. Now, if you're not on Linux, that's okay. You can use something like Notepad++ or CodeRunner for Mac, which we showed earlier in this course. So from here, what I'm going to do is I'm going to go ahead and enter in a shebang, which is a hash and an exclamation /bin /python3. And this is important for Linux here because we are calling out the directory. If you're familiar with Linux, what's happening here is we have two options. We can come in here and we can say python3 and we can say first.py and that'll execute our script. Or in theory, we can come in here, we can just do a /first.py and run it that way. If we run it like this, our script will not know where to go unless we declare that. So up here, we're giving the shebang /bin /python3. That is where python3 is located in this machine. So it will come up here and it will look for this first and say, okay, I'm going to execute this based on python3. So that is a little bit of a Linux nuance here and something you should know in case you are ever coding in Linux or an environment that is similar like Unix, which Macs do run off of. So from here, if you've ever taken a coding class, the first thing you do in every single coding class is what is known as hello world. So we're going to print out hello world and print it to our terminal. So in order to do that, we're going to go ahead and do something like this. We're going to say print, and then we'll do a parentheses and we'll say hello world. I'm going to go ahead and save this. And if we run this, and I'm going to run this with python3, if we run this, python3 first.py, you'll see that it says hello world. Now, one thing that we can do in here is good practice for being a developer is add some notes in. So we're going to add a comment in here. We're going to do a hashtag or a pound symbol, and we're just going to say print string. Now, when we run this again, this isn't going to print out. Comments are just for us inside of the script, and I can prove that to you by saving this and running it again. You'll see all we have in here is hello world. Perfect. So comments with a hash are just meant for whoever is reading your script or your code. And that could be you, or bad scenario, but what if you get hit by a bus tomorrow? You're the main developer and nobody knows how to read your code because you didn't leave any comments. That'd be very bad. So good coding practice suggests to leave good comments and make sure that people can come in and read your code and understand what is going on in here. So we're going to add comments along the way so that way we understand what we're doing and practice good habits as well. So what you're seeing here is what's called a string. You're seeing a string in quotations. And you can see a string printed out with single quotes as well. So we can just do hello world. I'll add the exclamation for consistency. And if we save this and print this, you'll see that it also prints hello world. So it really doesn't matter if you have single quotes or double quotes until we get into more advanced strings, and we'll talk about those a little bit later on in the course. But for now, just know that you can use single quotes or double quotes when printing out a string. Another thing that we can do with strings is print on multiple lines. So if we say print and we do triple quotes like this, we say this string runs, and then we hit enter, multiple lines with an exclamation and add in 3 more double quotes there. and close this off, we can add a note here as well that says triple quote for multi-line. And if we save this with Control S and we run this again, you're going to see this string runs multiple lines. Awesome. Another thing that we can do is concatenate strings. So we can print out something like this string is, and now we're going to add a space at the end of it. Make sure you have a space right here. We're going to do a plus sign, and then we're going to say awesome. Just like that. And we can say we can also concatenate. It's always hard for me to spell that. So what's going to happen here is it's going to take this string plus this string when it prints out. So the reason we have a space is it's got to have the space because there's no space here, and this won't just add a space for us, even though in our heads we might want it to. So we're going to go ahead and save this, print it out one more time, and you can see that it concatenated and said this string is awesome. Now, one last thing. We can also print out a new line. So we can just do something like this. And we can use a single quote this time just to do a proof of concept. Do a \n like this. And this will print out a new line. And we'll get familiar with that later on. As we get into functions, we'll write our own function to make a new line. But for now, if we wanted to add another line, we could, and then we can just print test that new line out. And let's see if it actually gave us a line printed in between this concatenation and this new print statement here. Let's go ahead and save that. We'll print it. And you can see there is a line here. So the \n will print out a new line for us. And that is all we need to know for basic strings. So we're going to go ahead and move on to math. You can go ahead and leave this open. We're going to run through this as we go, and then you'll have a long script, which will also make for very good notes. Let's go ahead and move on to math. So math. Python actually has a built-in math interpreter. So we can do a bunch of fun stuff with Python and with math that's automatically built in. So I'm going to go ahead and just call this section math. And if you want to keep track of sections, you can come up here and just call this strings and just capitalize it like that. And then that way we kind of have an idea of where we're at. You can even add an extra line here if we want to. So from here, let's go ahead and play around with math just a little bit. So if I wanted to do a print of 50 plus 50, we can definitely add. We can also subtract. So if you want to do 50 minus 50, you could do that. And I'll give you some time to catch up here in just a second. I'm just going to do a few print statements, then we'll take a look at them, and then we'll move on to some more math as well. We can also do 50 times 50. And we'll just use the little star or the asterisk. We'll just say multiply. And we'll also do 50 divided by 50. We'll just say divide. So if we save that, you could take a second to catch up. You could see we are just doing simple math here. We should expect 100. We should expect 0. We should expect 1 here and 2,500 if my mental math is correct. So I'm going to go ahead and print this out. Okay, and we've got 100, 0, 2,500, and 1.0. So this 1.0 is a little bit different. This is what's known as a float. Everything else that has come out so far is just an integer. And we'll talk a little bit about that here in just a few minutes, but know that integers are on the left-hand side. And if we don't have a decimal point here, we're looking at integers. And on the right-hand side, when we see anything on the right-hand side of the decimal, we're looking at what is called a float. And that becomes very important depending on when we need it. For now, we're going to keep worrying about math. We'll get into integers and floats in just a little bit. So another thing that math built into Python can do is it can do PEMDAS. If you've never heard of PEMDAS, please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. You may have had it something different within your educational experience, but it will do that for you. So if you do 50 plus 50 minus 50 times 50 divided by 50, it will give you the answer. I don't know that mental math offhand. Another thing that we can do are exponents. So we can print, say, 50 to the second power, which is the same thing as 50 times 50, which would be 2,500 as well. And we can get exponents out of this. And we'll actually go ahead and save this and run this here because the next stuff I want to be able to lay out clearly. So you can see that we have successfully done the math here. It did it for us. Awesome. And it also did the exponent for us as well. So now a couple of weird things with division. So you saw the 1.0 before. Well, we have a few things that we can do. For example, the 50 divided by 6, but using a percentage sign is what's called a modulo. And that, it just takes what is left over. So 50 divided by 6 is not divisible. There is a leftover. So if we print that, you'll see we get a leftover of 2, which makes sense because 6 goes into 50 8 times. 6 times 8 is 48. And then we have 2 left over. So if we want to know what the remainder is, we can use a percentage sign here. We can also do something like 50 divided by 6, like we saw earlier. And this will have division with remainder. So we can say or float. We'll save that and take a look at that really quick. You can see we get 8.3, and then it rounds up eventually to a 4. And lastly, what if we wanted no remainder? So if we just did 50 divided by 6, we say no remainder. We could do this, and we should get 8 here. So depending on the situation and what we want, we might want a situation where we only want the integer, or we only might want what's left over, or perhaps we actually want the full number of what's being divided. So there are a few different ways to divide with math in Python, and it's good to know all of them depending on the situation that you run into. So for now, just take notes on this and know that there are a few ways to do math and division, and you can do PEMDAS and exponents and all kinds of fun stuff. And this is just scratching the surface of math with Python. So that's it for this lesson. We're going to go ahead and move on to the next one, which is going to start covering variables and methods. So I'm going to come in here and I'm just going to call this section variables and methods. And if we want to make our script a little bit clean, we can just come in here and copy this new line. It'll be a lot easier once we write a function for this, but we haven't gotten there quite yet. So we're going to print out this new line, and that way when we print this out, you can see that we have kind of gaps in between the sections that we're working on. So now we're going to work on variables and methods. So variables. Variable means something can vary. It can change, and we're going to look at that here in a second. So if we have something like quote, and we make quote equal to all is fair in love and war. And this is what? This is a string. We are storing this string inside of this variable called quote. And we can just come in here now and we can print out quote. And if we do that, we should get this returned back to us. You can see all is fair in love and war. If we didn't print this, just go ahead. Actually, we'll just comment this out. This is a great way to test the script. If we just save this now with a comment and we hit enter, there's nothing here. We haven't given it any instructions to actually print out. So now we can print this out, and it's printing whatever is stored inside of that variable. In this instance, we have a string stored in there. Now, when we talk about methods, methods are just functions that are available for a given object. Now you could think of functions as something built into Python that allows us to do something. And it'll make sense here when we get into using methods. So we have this quote, "All is fair in love and war." Well, what if we wanted to print this in a few different ways? Well, we can use methods to do that. For example, we can print quote in uppercase and just do upper like that. And this is going to make it all uppercase because we're giving it this period, upper, and then open, close parentheses right here. And that is allowing us to use that method. So we can say uppercase. And we can also print in lowercase if we do lower. And just for one more, we can also do print, and we'll say quote.title. And this is what's known as title case. And title case will capitalize every single letter like it is the title. In this instance here, we're going to get like the A capitalized, which wouldn't really be true in a title, but still just know that title case is meant to capitalize every first letter within your string or your sentence in this case. We're going to call this lowercase here. Okay, so let's go ahead and save this, and we're going to print this out. And you can see the differences that we have. We have it here in its normal quote, and then we have it in uppercase, all lowercase, and then every single first letter capitalized. Perfect. These are methods. These are just a small example of methods. We're going to get into more a little bit later. Here's another example. What if we wanted to print the length of quote? Let's say we wanted to know how many characters were within this sentence. So this is going to count the characters. And this will also count spaces. So we're trying to get a total count of what's going on inside this string. We print that. You'll see that we get 28 return. So if you want to check that, you can go count every single character within here, and you'll get the length of that. And that could become important as you're doing Python later on. And this is just yet another example of a method. Now let's go back to looking at variables and why they're called variables. So let's say that we have a variable of a name. And in this instance, I'm going to use my name, and I'm going to make it a string. And I'm going to use my age. I am 33. And here we're going to say string just so we can make sure we notate the differences. This is an int or an integer. And we're also going to give a GPA. Let's say I went to school and I'm going to use the American grading system. Let's say I had a 3.7 GPA. And this is what's known as a float. And that has a decimal. So make sure you notate that. So if we print these out, if we print out the integer of age, that'll still print 33. What if we print out the integer of 30.1? Save that. Take a look. And you'll see that we just get 30. All right. And you can see that this rounded down. Again, integer, just the first number, just what's on the left side of the decimal point. Doesn't care about the right side. What if we printed integer of 30.9? Will it round? Will it round? No. So if we save that and we print again, you'll see it's still 30. It doesn't care what's on the right side of the number. It's only going to take what the integer is. So anytime you print an integer, you're only going to get the first, or what's on the left-hand side of the decimal point. So make sure you know that. Now, a few cool things that we can do. Let's say that we wanted to print something like this. If we print my name is with a space, and then we'll do plus name, and we'll say space again, and I am space age plus space years old. Make sure you have your spacing in there properly. That way you can account for the spaces before and after these variables. But what are we doing here? We are concatenating variables. Now, if I try to run this, I'm actually going to get an error. If I run it, we're getting a type error. And this is a great example, by the way, of understanding what Python is telling you. I get emails all the time from students saying, I don't understand why my script isn't working. And the first thing I'll ask them is I will say, did you read the output of the error? Because it tells you, it says, hey, on line 44, if I control tab, look, this is line 44. It tells you where your mistake is. And then it also says, can only concatenate string, not int to string. So if you didn't know what this meant, and maybe you don't, you can copy this, go to Google and search it, and I promise you somebody will have had this error before. As much as we wish to be special, there's not many situations that will come up where there hasn't been this error or an issue that we run into that somebody hasn't already had before. So with that in mind, we can fix this. So it's saying that it can only concatenate strings, not integers. Well, name is a string, but age is an integer. So we need to make, in this situation, age a string. So what we're going to do is just say str, like this, and give it like that. And now if we print this, save it, print it, you can see my name is Heath and I am 33 years old. Perfect. Now, what happens if I am a year older? Well, I could take age and do something like plus equals 1, something like that. And if I print age now, hopefully, we are seeing 34. You can see 34. Now, this is what comes into play. This is a variable. Variables can change. At this point in the script, we define that we are 33. And as we run through it, I am still 33 when I print this statement out. However, I've had a birthday now. Age has increased by 1. Printing age out now will say that I'm 34. So variables can change. Variables can store different numbers at different times. That's why they are called variables, because they vary. Now, we could also do something like birthday and set birthday equal to 1. And I could say age plus equals birthday and then print age. And guess what? Now it's going to return 35. So just know that you can store a number within a variable. We've shown that before already. We can add two integers together and we can print them out. So we're adding those together and it's taking that total and adding that to age. And now it's saying we're 35 years old. So that is it for this lesson. We're going to go ahead and move on to functions and fix this new line issue that we've had, plus write some pretty cool stuff out and build some other cool functions out as well. So I'll go ahead and see you over in the next lesson. All right, moving on to functions. So let's go ahead and print out a new line really quick. And we're going to call this functions. Now, I like to think of functions as mini programs. What they are is an organized block of code that you define, and then you can call it later instead of repeatedly typing the code out. So we're going to take a look at some examples of that. So let's go ahead and write a function. So let's do a define, def, and that's how we start a function. And in this one, I'm going to say, who am I? And I'm going to do close parentheses. And here we're going to say, this is a function without parameters. And we'll talk about that here in just a little bit. Now, indentation is incredibly important in Python. If we do not indent, we will throw an error here. And you're going to see a lot of situations where indentation becomes incredibly important. It's one of the most important things in Python. Python does not have a lot of rules that apply to it, but indentation is one of them that you must follow. So we're going to go ahead and hit the tab to indent. And I'm going to say my name is Heath. And this is what is known as a local variable. We'll talk about that here in a second as well. Age is equal to 30. And we're going to go ahead and print. Same thing we did before. We can actually just kind of copy this up here. We'll say my name is just like this. Okay. Copy all that, paste it, and then add the close parentheses there. I'll let you catch up. And then we can just call down here, who am I? So what's going on in here? Well, we have a function that we're defining. We're calling it who am I? And it has no parameters. We'll get into parameters here in just a second. Now we're giving it some items within this. In this instance, what we're doing is we're giving this local variables. We're saying, hey, in this instance, when we have a variable of name, it's going to be Heath, and the age is going to be 30. Well, whatever is stored in here is only stored within the function. That's why this is a local variable. If we print age as well, we'll see that. So we know that age was 35. We called age over here as 30, and let's see what happens. First of all, we called our function here. We said, who am I? Called that. And all it does is run our mini program. Our mini program says, hey, I'm going to print out these variables into this string here. Okay. And that's exactly what it did. But when we printed age again, you could see that we're actually still 35. So this variable, or the variables that are within a function, are local and do not apply outside of the function. So make sure to remember that. Okay, so I'm going to delete this print statement. We don't need it. And we're going to write some more functions. So let's do one where we add some parameters. So we're going to do add 100. And we're going to give this a parameter of num, N-U-M. And that's just going to stand for number. Okay, we're going to indent, make sure we indent. And all we're going to do is print num plus 100. So when we call our function, we say add 100, just like last time. This time we have to actually give it what is called an argument. So our argument goes with our parameter here when we're calling it. So our argument is going to be 100. And when we print this out, this is going to be 200, hopefully. So we'll save this, run it. And you can see that we got 200 because we're doing print 100 plus 100. That's all we're doing with this mini program. Okay, let's try another one. Let's say we want to have multiple parameters. Let's do define add, and we're just going to add X and Y. This one's going to be easy. We're just going to say print X plus Y. And now we can add whatever we want. So let's add 7 and 7. And one will take the place of X. The other one will take the place of Y. X plus Y. 7 plus 7 should be 14. Let's go ahead and run that. You'll see we get 14 here. Beautiful. All right, let's make it a little bit more complicated then. All right, let's try adding in here another function. This time we're going to do multiply. We're going to do X and Y again. And instead of doing a print, I want to show you something a little bit different. Let's say we just return X times Y. And now in this instance, if we multiply 7 times 7, do we get 49? We don't. Okay, there's a reason for this. This is just calling back. So when this is saying return, this isn't saying print. Remember, this says print. This is going to return X times Y. So we can call this here, this function, and it knows that this function is equal to 49, and perhaps we can put that into something else. Like we can put that maybe into a variable or whatever it is we might want to do with it. However, if we wanted to return to the screen, we actually have to call that. So sometimes we're going to actually store something instead of printing it. We do a lot of printing in Python tutorials just so that you can see it on the screen and make sure that you're seeing what you're doing and that everything's printing out okay. So that's why we're doing this. But please understand that the return option does exist and is used quite frequently. So I'm going to save this and run this. And you can see now that we get 49. Perfect. Okay, 2 more. Let's say we want to do a square root. Okay, so let's define square root. And we're just going to give it 1 parameter. And in this instance, we're going to print out the square root. So we're going to take x, and a square root in exponent format is just to the power of 0.5. That's all we're doing. And we can test that theory by doing something like square root of 64, which we should return as 8, because 8 times 8 is 64. So if we save that, come in here, print it, and you can see we get a float of 8.0. Now, I told you we would create our own function for a new line, and we're going to do just that. Let's go ahead and define new line. And we could call this like new line if we wanted to or whatever, but I think to make it simple, as long as we understand what it is, we can make comments and notes in here if we wanted to. We could just say define NL, and then we can just say that when we do that, we're just going to print out our N for our new line. And then we call a new line, we'll get one. Very simple. So we can just even say in here, new line. Okay, so now we know. And we save that, and we can print it. You'll see it. It's here, but we really don't have anything after it to really show it, but we do have that space there. So that is it for this lesson. I'll go ahead and see you over in the next one. Next up, we're going to learn about Boolean expressions and also relational and Boolean operators. So let's go ahead and type in here Boolean expressions. And when we think of these, we can just think of this as true or false. And that's really what it is. So from here, let's do a few variables. So we could set bool1 equal to true. We're just going to say, hey, this variable's true. Bool2, we could set equal to 3 times 3 is equal to 9. So the double equals means that something is equal to something. So we have 3 times 3, that's 9, equal, that means that equals 9. Do not confuse that with setting up your variable. This is saying, hey, my variable is equal to this, but this is saying this is equal to this number. Okay, and that is a true statement. We could also say bool3 and make that false, or we can give it a statement that makes it false. So something like 3 times 3 does not equal 9. Exclamation equals means does not equal 9. Now, if we print it out, bool1, bool2, bool3, and bool4, just like that, and save it, and if we come in here, you'll see that it says true, true, false, false. Again, Boolean expressions. Is something true? Is something false? Why do we need to know this? Well, we need to know if something is true, then we might want to continue on. Or if something is false, we might want to do something. And we'll get into that when we get into conditional statements. Like, if something is true, then go ahead and do this. If something is false, do this. Or there's something called while loops, which will allow us to continue as long as something is true. We're going to get there when we get to conditional statements as well, or looping, I should say, and we'll talk about that. But that is why we might want to know these things. Among other stuff, we might want to know if something's true, or set that parameter or that variable to true until it becomes false, etc., etc. So right now, just understand that Boolean expressions are true or false. And we're going to come in here and we're going to print, and we're going to say type, and we're going to do bool1. Okay, and this will tell us. Now, this is the nice thing. So if we come in here and say type, it'll give us the class. This class is Boolean. Awesome. And another example of that is if we say like bool5 is equal to true, and we print the type. So if you see true and you're like, I wonder what that is. Is that Boolean or is it actually just a string? We can come in here and say bool5. We save that there, and then you should see that that class is actually a string here. So you can check with the type to see what is this. Okay, so the type feature is very nice, and we can see that we are dealing with a Boolean here, and this one is actually a string. So please note that if you put it in quotations, that makes it a string. If you leave it like this, that makes it a Boolean expression. Let's go ahead and make a new line, and we're going to talk about relational and Boolean operators. Okay. So we can think of that as, let's make a variable here. We say greater than, we say 7 is greater than 5. Well, that would be true. And we are using an operator here. So the operator is the greater than sign. We're also using a Boolean expression because it's going to result in a true returned if we were to print that out. Now, we can do a few other things. We can say like less than is equal to 5 is less than 7. We can do greater than or equal to, which would be 7 is greater than or equal to 7. That's true. We can also do less than or equal to. And in that case, we can do 7 is less than or equal to 7, which is also true. So all of these statements here are true. Now we can get into some other type of operators and statements here. What if we did and? So let's just call this test, and we're going to do test and. We say 7 is greater than 5. Well, that's true. And 5 is less than 7. That's also true. Both statements are true, thus this is true. Do another one. Test and 2. And for some students, this does take a little bit to get your head wrapped around. I'm going to provide a table for you here just in a second, but just follow along and I'll explain this as we go. Let's say we have 7 is greater than 5 and 5 is greater than 7. Sorry, let me fix that syntax. 5 is greater than 7. This now becomes false. Why? Well, 7 is greater than 5 and 5 is greater than 7. That's not true. So, because it's not true, because both statements are not true, this becomes false. There's an alternative to this. What if we had an or? We said or. So 7 is greater than 5 or 5 is less than 7. Well, both statements are true. Thus, this is true. But we can have the same situation as before, where we have 7 is greater than 5 or 5 is greater than 7. And guess what? This statement is actually true. Because all we need is one condition to be true for this to be true. So in this situation, this is true, or if this is true, then the whole thing becomes true. So just because this is false, this would also have to be false for this to be false. Hopefully that makes sense. One other thing here, before I show you the cool little table, is we could do test not. So if we said something was not true, guess what? That becomes false. Same thing, if we said it was not false, then it's true. Not is just the opposite. So not true in this situation is false. Now, if we go out to the internet and we go to Google, we could come in here and we can just search something like Python truth table. And if we go to images, we should be able to find one that works out pretty well in our favor. Here's a good example right here. So if you ever take a coding class, you might be quizzed on this. This will tell you truth tables right here. So if it's not false, it's true. If it's not true, it's false. We can look at or statements. So true or false is true. The only situation an or statement becomes false is when both are false. Now the and, we looked at that. If it's true and false, it's false. If it's false and true or false and false, it's still false. Only situation for and where it can be true is when both are true. There's also not or, not and. There is does not equal or equals. So it's good to know these types of truth tables, and you can come and just, again, Google Python truth table and come look up this. Pretty straightforward once you get the hang of it, but it's completely okay for right now for it to be confusing. Just wanted you to know that these are out there and exist in case you are a little bit confused by this lesson. So we're going to go ahead and move on to the next lesson, which is going to cover conditional statements. Okay, we'll come in here, we'll do a new line, and we'll just say conditional statements. And we can think of this as if, then, or if, then, else, or if, else. Either way you want to write this is fine. So think about this. If you go to the store and you want to buy a drink, and that drink is $2. If you have $2 or more, you can buy the drink. If you do not have $2, you will not be able to buy the drink. So let's take a look at that. So if we write a function and we call it define drink, and we give it a parameter of money, we come in here and we say if money is greater than or equal to 2, then we're going to return. Look at the indentation again. We need an indent here after our function, and we need an indent after our if statement. So make sure you're indenting correctly. Return, you've got yourself a drink. And here, we come back, we can say else. We're going to return no drink for you. Kind of like Seinfeld, no soup for you. All right, so if we come in here and we print drink of 3, meaning we had $3 at the time, and we print drink of 1, meaning we had $1 at the time, we're going to have 2 different results. If we have 2 or more dollars, we're going to return you've got yourself a drink. Otherwise, if we have less than $2, we're going to say no drink for you. So let's save that. You've got yourself a drink when we print out $3 because we had enough money. Here you can see with $1 we did not have enough money, thus no drink for us. Okay, let's take a look at a little bit more of a complicated one. We're going to come in here, we're going to say define. Now, I'm going to make this alcoholic beverages. If you do not drink, that's okay. You can just follow along still. You can change it into whatever you want to be. But I think this is a good example because we have a couple parameters and we can use those to make different sort of conditional statements. So let's define alcohol. Now, in the United States, we have 2 things that we need in order to purchase alcohol. 1, we have to be old enough. We also have to have enough money, similar to the drink before that was non-alcoholic, we assume. Well, we have to actually be old enough to purchase this drink. In the United States, you have to be 21. So, if our age is greater than or equal to 21, let me put a space here, by the way, sorry. And, look, the and is coming into play. Money is greater than or equal to 5. Then we're going to return, we're getting a drink. All right. Now we're going to say else if, because there's a few situations that we can be in. There's actually 4 situations here. So we're going to say ELIF, which stands for else if. What happens if our age is greater than or equal to 21 and we don't have enough money? So we say money is less than 5. Well, in that situation, we're going to return, come back with more money. Okay. And then what if we have another situation where we say age is less than 21 and we actually have money? We're just an underage person trying to buy a drink and we say $5. Well, we're going to return, nice try, kid. And then lastly, if we have no monies and we're not old enough, well then we can just return something like you're too young and too poor. Okay, and then let's try these out. So we've got these different situations here again. Okay, if we have our age and money, we meet both criteria, we're getting a drink. Otherwise, if we meet the age but no money, let's come back with more money. We don't meet the age but we have the money, nice try, kid. And then lastly, if you don't have the money and you're not old enough, you're going to be too young and too poor. So we're going to print out a few different statements here of this function. So let's give it 21 and 5. We'll print alcohol again of 21 and 4. Print alcohol of 20 and 5. And these should all meet different criteria, alcohol of 20 and 4. So we should expect to get these in order. We meet what we need here. We don't. Different criteria for each of these. We'll save this. Go ahead and run this. And you can see it says, no drink for you. Actually, that's the last one. We're getting a drink. Come back with more money. Nice try, kid. And you're too young and too poor. So you can see that we can make conditional statements based on everything that we're starting to put together here. We have now used a function. We've used multiple parameters. We've used a conditional statement. We've used relational operators. Okay, we've got the Boolean, right? This is true and true. We're returning something. This is true and true in this situation. Then we're going to return something else. So we have different situations that can come back. So we need to meet those criteria, and we're starting to use that. Look, we're using the return instead of the print feature. There's a bunch of different things that we're doing here that's all starting to tie in. And hopefully that's starting to make sense why we do things. We're starting to build upon it, and it's starting to get a little bit more fun. So from here, we're going to go ahead and move on to lists and move on with our journey into Python. So I'll see you in the next lesson. Let's move on to lists. So let's go ahead and do our new line, and we'll call it lists. And the best way to think of lists, in my opinion, is that they have brackets, something like this. Now, lists are data structures. They are changeable. We can reorder them. They are basically just a group of elements. Now, everything within a list is called an item. And as I mentioned, the best way to think about lists is that they have brackets. Just like a string might have quotes around it, lists will have brackets around it. Now, again, we need to remember these are changeable. We'll talk about something here in a little bit that is not changeable, which is called a tuple. Now here, let's go ahead and declare a list. We're going to say movies. And I'm just going to list out some movies that I like. And we can do a bracket, and I can say when Harry met Sally. We'll just give these as strings. I like The Hangover. And I like The Perks of Being a Wallflower. Now you can add whatever you like here. And my hangover here, by the way, I have the hangover here. My hangover on the line here is just because my notepad here is not wide enough. If I made it wider, it would actually just continue on. So don't confuse this. If I hit enter, you'll see it goes to 148. So my wrapping does not mean I went into a new line. And lastly, we'll just say The Exorcist. Okay, and we'll close the list off with a close bracket. So if I wanted to print the first movie in the list, if I wanted to print When Harry Met Sally. I come in here and I print movies, and I wanted to say 1. Do we think that would print the first item in the list? Go ahead and hit save, print, and you're going to see that it actually prints The Hangover. So what am I doing here? I am calling an index, and our index actually starts with the number 0. So when we look at an index, we need to think of it as 0, 1, 2, 3. Always count starting with 0, not 1. Otherwise, you can return the wrong numbers, and this can get very confusing. Let's make sure we add a note to this. Returns the second item in the list. Okay, we're looking at the second item with the index of 1. If we printed, for example, movies, and we gave it 0, then we would see that this will return the first item in the list. Okay, we'll save that, take a look real quick. You could see that the first item is When Harry Met Sally, and that's exactly what we're getting returned, which is what we want. Now let's look at a few tricks to splicing an index or indices. We can say something like print movies. And if we printed movies 1 to 3, what would happen here? Well, what's going to happen is it's going to return the first item given. So this is going to be index number 1, which is item 2. So first index number given right until the last number given. It's not going to include the last number. We'll even say, but not include the last number. So, no, it's a lot. Let's just print it out. Take a look. So 1 to 3 will print The Hangover starting at 1, and The Perks of Being a Wallflower, which is 2, it will not print 3. Okay, so make sure you understand if you go 1 to 3, you're only going to include 2 items, not 3 items. Now, you can also do 1 to 4, which would print all of those. If you wanted to print everything from the beginning of a number, so say we wanted to print movies 1 and we wanted to go all the way to the end, we could just do something like this. We could start from a certain point in index, print The Hangover, Perks of Being a Wallflower, The Exorcist, and we're skipping When Harry Met Sally because we're not starting at 0. Okay? We could also do, in the opposite of that, movies. And remember, if we go to 1, it's not going to include 1. It's only going to include the first item here. Everything before. So When Harry Met Sally. Everything up until this point is another way to think about it. Okay? So if we wanted to print 2 items, we'd actually have to add a second or put the number 2 here, and that would include The Hangover. That's what we wanted to do. Now, another thing that we can do is if we wanted to print the very last item, we could do a movies -1. And you don't need to commit all this to memory right now, especially if you're not working with lists. But if you ever do work with lists, you need to pull specific items down from a list. This becomes very important. So it's important to know that indexes or indices exist. You start at 0 and then you move forward, and then the way that you can splice these just depends on how you call these. Now this will return last item in list. We save that, take a look. You'll see it'll return The Exorcist here. Now we can apply methods to lists, just like printing length of movies. We'll count the items in the list, right? In the list, and we'll save that. Just take a quick look. I never closed this, sorry. So you can see it tells you your mistakes, and even I make mistakes. Come in here, try it again. You can see that we have 4 items within our list. All right, so, and that is true. We have 4 items in the list. We can also add to the list. So we can use something like movies.append. We'll add to the list. And if we wanted to add the movie Jaws, we could. And if we printed movies, you'll see that this appends to the end of the list. Let's go ahead and save that. And you'll see now that JAWS is here at the end. Now, we could also insert a movie into the list. So if we did movies.insert and we wanted to put in a specific spot. So say we wanted to put it in index 2, we could say 2, and then we could give it a movie, Hustle, the movie I just watched recently and really liked. And we can come in here and print movies now. We save that. You can see that we can actually insert Hustle here into position 2 on the index. So pretty neat. Now we can also remove movies. We did movies.pop. Come in here and that will remove the last item. So if we come in here, add a print statement really quick, save that and then print this out, you'll see that JAWS is now gone. We can also specify specific spots we want to remove. So if we want to remove index 0, we could, and then this will remove the first item. Print movies, save, go ahead. And When Harry Met Sally is now gone from our list. We can also combine two lists. So if we come in here, and let's say that my wife has favorite movies, and she definitely does, and we'll just go with a couple of her favorite movies. She likes Just Go With It, and she also likes 50 First Dates. Come in here and close that off. Well, we can combine movies. Let's say we wanted to know our favorite movies. What we can do, we can combine lists, I should say. Come in here and I could say, I want to add movies plus Amber movies. And I can print our favorite movies. And then I have now combined lists. Let's go ahead and take a look at that. Hopefully I did it right. And you can see now The Hangover, Hustle, Perks of Being a Wallflower, Exorcist, Just Go With It, 50 First Dates. You could also just come in here, if you copied this, by the way, and just pasted this. You don't have to put it into a variable. You could totally do it like that. But I think storing in variables is a better practice. So I'm going to go ahead and just Control Z here. And one more thing. So we can also have what are called 2D lists. So two-dimensional lists. So let's say, for example, we have grades. And we have a list of grades, and we're going to say that inside this list, we have Bob, and his grade is an 82. And then we have Alice, and she has a 90. Okay, and then we've got Jeff. Jeff's not doing so hot. Jeff's got a 73. Okay, and let's say we wanted to pull down Bob's grade. We could make a variable, like, just call it Bob's grade. And we could set that to grades and then do something like 0, 1, like this. And what are we doing here? Well, we're saying, I want to pull from the first index, okay, index 1, or 0, right? First index, 0, 1, 2. So I'm pulling from 0. And within that, I want to pull the second item, which is this, 0, 1. So we have a two-dimensional index here. And if we went ahead and printed Bob's grade, you can see now, if we save this, we get an 82. Well, that's correct. What if we screwed up Bob's grade and we wanted to fix it? Well, we could also do something like grades 0, 1, just kind of like we called, and we could just set it equal to 83. Maybe it was an 83. Okay, we come in here and we print out grades. You should see that this has changed. So let's go ahead and print this. You can see now Bob has an 83. So we can modify our 2D lists as well. So that is it for lists. Remember, lists have brackets. Lists are data structures. We can change lists. As you saw, we were able to append, pop, insert, remove, Okay, we can modify many different ways. We're going to move on here in a second to what are called tuples, and tuples cannot be changed. Even though they look very much like lists, they are different. So I'll go ahead and see you over in the next lesson when we cover tuples. Okay, let's talk about tuples very quickly, and then we're going to move on. So do a new line, say tuples. And these are like lists, but they do not change. We'll say do not change, and then they get parentheses, as opposed to getting brackets. Okay, so we might want to have something that doesn't change. And when something can't change, we say that they are not mutable. M-U-T-A-B-L-E. They're not mutable. So that means that they're immutable. And tuples are immutable, meaning we can't change them. So we think of lists mutable, tuples not mutable or immutable. So if we have a tuple of grades, we can say something like grades are equal to A, B, C, this is the American grading system, D, and F. Come in here. If we did something like grades.pop, like we saw before, or grades.append, something like that, neither of these are not going to work. Or neither of these will work, I should say. Proper English. What's going to happen is they're not mutable. We can't change them. Once we have this and we store it, it does not change. So if we want something that is like a list, but we don't want it to change, it's better to use a tuple. We can set something in stone, like our grade letterings, and then we can call those when we need to. We can just say something like print grades and give it a 1 and save it, and we should get a B back. Okay, and we get a B back. So that's it. Just know the difference between tuples and lists, in that tuples do not change, but they are very similar in how they can function, and there are pros and cons to each of those. We're going to go ahead and move on to the next lesson, which is going to be looping. Okay, so let's come in here, make a new line, and we're going to call this looping. So we're going to talk about two different types of loops. The first type of loop that we're going to talk about is what's called a for loop. And for loops are start to finish of an iterate. And here's what a loop looks like, and we'll take a look. So let's go ahead and get a list. We're going to say vegetables, and you can put whatever vegetables you want in here. I'm going to go with a cucumber. I'll do some spinach, and then we'll do some cabbage as well. And now what we're going to do is we're going to come in here and we're going to write a for loop. We're going to say for x, and x could be whatever you want it to be. You could say for veggies. It could be whatever you want to call it. In this instance, I'm just going to call it x in vegetables. So for x in this list, we're going to go ahead and print out x. So what do you think this is going to do? All this is going to do is just loop through the iterates, start to finish of an iterate. So it's going to say cucumber, spinach, cabbage. Let's go ahead and give it a go, save it, print it. Cucumber, spinach, cabbage. All we did was go through a list, iterate through it until we reached the end of the list, and then it stopped. So that is a for loop. Another good example of a loop, if you want to think about it, might be trying to ping an IP address, so like a 192.168.1.1, or maybe you have 1.x. Maybe there's a whole slew of IPs that you want to ping. Maybe it's 1 through 254. Okay, if you wanted to ping all of those, you might want to do something like a for x in IP, and where IP is just equal to like a sequence. Like say IP is like a sequence of 1 to 254. And don't worry about this, I'm just logically writing this out. So if you say IPs 1 to 254 for X and IP, and then you want to do something, you might want to like ping 192.168.1.x. and then x will be 1, then 2, then 3, then 4. Okay, so you could write something like this for a ping sweeper. Again, it's a start to finish of an iterate, 1 through 254. We'll stop at 254 when the iterate is done. Now, another example of this, or another example of a loop, is what we call a while loop. We say while loops. These execute as long as true. I should probably capitalize true, so that way it makes sense that we're talking Booleans. So let's think about this situation. What about we set I equal to 1? So we've got a variable of I equal to 1, while I is less than 10. We're going to go ahead and print out I, and then we're going to say I plus equals 1. So what's going to happen? Well, while I is less than 10, so right now, I is equal to 1. 1 is less than 10. That is true. We're going to go ahead and print I, increase the value of I by 1. So the next time it loops through, it's going to be 2. And it's going to continue on until this is no longer true. So if we save this, this should print out 1 through 9 because we're not looking for 10, just 1 through 9. So we're going to say that, hit enter, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it looks like the loop actually did its job. So again, we have two types of loops. All we need to know about right now is we have a start to finish of an iterate. That's a for loop. Then a while loop executes as long as true. We may see these later on as we do our project work. So keep these in mind as we go on through the course. So from here, we're going to go ahead and move on to advanced strings. So I'll see you over in the next lesson. Okay, let's take a look at some advanced strings. So if we come in here, again, we do a new line. So go ahead and enter advanced strings. And let's create a variable of my name. I'm going to say my name is Heath. Now, let's say we wanted to print my name and we wanted to grab the first letter of my name. How do you think we might do that? Well, if you're saying index of 0, you are absolutely correct. And we can say in here first letter. What about printing the last letter of my name? Well, if you say -1, you have remembered your index lessons. Great job. That's going to be the last letter. We can save this and we can go ahead and print. And if I made this a string, that would be very helpful. Go ahead and save this. You can see that we get the capital H and the lowercase h here because my name starts with an H and ends with an H. So, another thing to note about strings, much like tuples, they are also immutable. You cannot change a string. We cannot modify the string. We can join strings. We could split strings, and we'll talk about that here in a second. But once I have set this variable in this string is here forever. I can always change the value of this variable, but you cannot change this string. So again, strings are immutable. Now let's go ahead and say we have a sentence. And we give that something like this is a sentence. If I can type today. And we print out sentence with something like this. What do we think that's going to look like? Let's save this, print it. You can see that we get this. What are we doing? Well, we're just grabbing this first word. However, we have the benefit of knowing what the first word is and how long it is. So we went 0, 1, 2, 3. Remember, we stopped at 4. So we grabbed the word this. Well, what if we were in a situation where we didn't know what the word was or how long the first word was? We could use something like a delimiter. So we could say print, and we could do sentence dot split. And if we do a dot split, we can just do it like this. And then this is a delimiter. And a delimiter says we're going to take something and we're going to split based on that. Now, the default delimiter in Python, if we just give it a split, is a space. So we save this, come in here. This is a sentence. Now, look at it, it's in a list. We could pull the first item if we wanted to and know the first word instead of having to split it like this or pull it out like that. So we could do something like this as well. This is just a proof of concept that's a little bit fun. We go sentence, split, and we say that is equal to sentence dot split. Okay, and then we also create another variable and we call that sentence join, and we say that is equal to space. We're giving it a delimiter to join on. Actually, we're telling it what to add in between the different words that we're pulling out. So we're adding a space here. And we're going to say join sentence split like this. And if we print out sentence join, what do you think we're going to actually have happen here? I'm going to save it. Guess what? This is a sentence. So all we did was deconstruct this sentence based on the delimiter. It came out to this is a sentence, and then we joined it back together with a space. So every one of those got a space in between, and that's it. So that's just a nifty little way to show you that splitting and joining is possible. And again, this is still immutable. Even though we're messing around with the strings are immutable. So let's take a look at a few other things here. I mentioned in the beginning of the first lesson when we were talking about strings initially that we might have different ways of using single quotes and double quotes. And think about this, like what if we had a situation of quote and we wanted to say something like, he said, give me all your money. Well, with this situation, what are we going to do? What if we wanted to add quotes here and say, give me all your money? We do that because that is a quote. Well, it looks like it's kind of messed up. We're not seeing it in green. It kind of looks funny. What we can do in this situation is we can use single quotes if we wanted to, or we could flip this around, by the way. We could use single quotes on the outside and then double quotes on the inside if we wanted to use double quotes here. And I could save this. Let's print out quote just to show you, and then we can save this. Another thing that we can do, though, is we can say something like quote, and then we can just do he said, and we can do character escaping. So we can do give me all your money like this. And now Python knows that everything within these escaped characters is ignoring this double quote here and ignoring this double quote here. So we're escaping that, and then we can print it, and hopefully we did this right. Go ahead and print. You can see now it says he said give me all your money in double quotes, while we also use double quotes on the outside. So we can use character escaping if we want to. Just know that we'll have to use this backslash in front of each of the characters that we want to escape. Okay, let's take a few more examples here. So if we say something like a variable of too much space, what happens in a situation where we have, like, you can just add as much space as you want in here. It doesn't really matter. We have a string with a lot of space in there. Well, we can strip this out. We can print too much space, and then we can do a dot strip. And the strip is going to take the delimiter of a space as default. And that will also strip this out. You can see there's just hello there, nothing else. So that's kind of nice. A few more items. What if we have the letter of A and we have the word of apple? Okay. Well, what if we wanted to know something like this? Let's actually go up a little bit. And let's say we wanted to know, like, print A in apple. Okay, and what is this going to return? Go ahead and if I could type, sorry. And this is going to return something. Let's go ahead and save that. That's going to return true. So we'll just say true. Now, if we print A in apple, you're going to see that this is going to return false. Save this. Why? Well, this here is a lowercase a, and that does not exist within apple. So even though we're looking for a specific letter within a word, we have to match case sensitivity in order for that to return true. So if we wanted to know if the letter A was in the word apple and we weren't concerned about case sensitivity, then what do we do in that situation? Well, this brings something up that we did a little bit early on, which is using lowercase. Remember the lowercase method. We can say print, and then we can come in here and say letter.lower. You could also do upper if you wanted to, but what we're doing is we're converting all of this to lowercase. So this is now going to be a lowercase a, and then we could say in word.lower, and we can just say this is an improved way of doing this. So if we print that out, we save this, this should come back as true. So think about when you're trying to match a word or a string or anything, and if somebody came in and you were expecting, like, I don't know, like think about school, and we're thinking about a word, maybe like Manhattan, I don't know, and somebody types in Manhattan like this. Okay, we still want to be able to accept that answer is true, even though they may have screwed up a little bit on the punctuation. Now, there could be instances where we want a capitalized letter and it has to be very specific. In that case, this kind of syntax works. But if we're looking to just accept an answer, like Manhattan for Manhattan, then we might want to consider using lowercase or uppercase in that situation just to match those words or letters or whatever it might be. So one more thing. Let's look at what is called string formatting. So if we do something like movie, we'll pick The Hangover again. We say The Hangover. You can pick whatever movie you want here. There's a few ways that we can print this out. Remember, we concatenated early on, and we said like print. We did something like my favorite movie is space plus, movie, something like that, right? Well, we can actually write this in a certain way that is a little bit easier. So there's a few things that we can do. For example, we can do my favorite movie is, add a couple brackets in here like that, and then we can add period at the end just because we're going to close our sentence. We'll say dot format, and we'll say movie and close that off. That's one way of doing it. Okay, if we save that, you can see my favorite movie is The Hangover. Okay, this is called using the string format method. Now, what we can do, there's another type of method we can use, is we could say print my favorite movie is %s, and we say %movie, just like this. Save that. This is using % formatting, and look, the same thing happens. I just forgot my period in there, so no big deal. Lastly, if we print out an F in the front, this is called an F string, or what's known as a string literal. We can do my favorite movie is, and then just do movie like this. Super easy. And we have moved off of using the format method and the % method into this F string or string literal. And we come in here and save this, tab up, print, and you can see my favorite movie is The Hangover. So that worked out perfectly well. You can use any of these to format, but just know that the F strings are the latest and the greatest way of doing it in Python 3. So that is it for this lesson. We're going to go ahead and move on to dictionaries. Okay, so we'll add new lines in here, and we'll say dictionaries. And we can think of these as key value pairs. And also think of these with the curly braces like this. So we've seen lists like that, and we've seen tuples. Now we can think of dictionaries with the curly braces. So let's go ahead and we're going to put some drinks. And again, I'm going to use alcoholic beverages. You do not have to do that. You can use whatever drinks and prices in here that you want, but we're going to have a key value pair. So our key is going to be the drink. So first drink I'm going to pick up is a White Russian, and the value is going to be 7. Let's say that a White Russian costs $7. If we do an old fashioned, we're going to say that this costs $10. And we'll do one more. We'll do a lemon drop, and we'll just say that this costs $8. Okay, and we can make a note here to ourselves that drink is the key, price is the value. Remember, key value pairs, key value. All right, so we've got our drinks. We can print our drinks. Save this, go ahead, print. And you can see we print out our dictionary here. Now, let's give it